It turns out that when you differentiate a trigonometric function, you get a trigonometric function. Kind of cool. In particular, the derivative of the sine function is equal to the cosine function. The derivative of the cosine function is equal to the negative sine function. And like right now is the time for you to straighten out which one has a minus. What I would recommend is that you memorize that the derivative of the sine of x is equal to the cosine of x. Then you know for cosine, it's the other one. Let's keep going. The derivative of the tangent of x is the secant squared of x. We're going to see where the differentiation rule for the sine function and the tangent function come from in a video later in this series. Let's keep going. The derivative of the cosecant of x is equal to negative cosecant of x times the cotangent of x. The derivative of the secant of x is the secant of x times the tangent of x. And the derivative of the cotangent of x is the negative cosecant squared of x. This is a lot to memorize, but I'm going to try to help you out a little bit. First off, you'll notice that all of the trigonometric functions that start with a c, that is the cosine, the cosecant, and cotangent, all have minus signs in their differentiation rules. That is a really happy coincidence. Here's something else to note. The tangent and cotangent are cofunctions, and the secant and cosecant are cofunctions. So that's a way to try to remember how they're related. Likewise, the secant and cosecant are cofunctions, and in their differentiation rules, we have secant related to cosecant and tangent related to cotangent. Here's what I would recommend. Memorize the differentiation rules for the sine function, the tangent function, and the secant function. Then remember how the other ones are related to those. That way you're memorizing 3 things instead of 6. Here's another thing. Sine tends to go with cosine. You may recall there's a Pythagorean identity that says the sine squared of theta plus the cosine squared of theta is equal to 1, which doesn't have anything directly to do with calculus, but it's to say that the sine goes with the cosine in the Pythagorean identity, and in their derivatives, it turns out to be the case as well. Further, there's a Pythagorean identity that says that the tangent squared of theta plus 1 is equal to the secant squared of theta. Now again, this doesn't relate directly to calculus, but it's to say tangent goes with secant. And I see here that in the derivative for the tangent, we have the secant, and in the derivative for the secant, we have the secant and the tangent. They tend to go together. Now we're going to learn several of these probably by exposure, just seeing it enough times, but it would be worth your time to memorize these as soon as possible. And to help with that, let's see them in use. We're going to differentiate y equals x squared times the sine of x. We have here a product. It's the derivative of u times v. And the derivative of u times v is u prime v plus uv prime according to how I remember the product rule. Here we're going to say that u is equal to x squared and v is equal to the sine of x. Therefore, u prime is equal to 2x, v prime is equal to the cosine of x, and y prime being u prime v plus uv prime is going to be 2x times the sine of x plus x squared times the cosine of x. And that's it. This can't be simplified any further. We could factor out an x if we wanted, but there's nothing to be gained by doing that right now, so we're not gonna. Next up we have y equals the sine of t over t plus the tangent of t. Here we have a quotient, and the derivative of u over v is equal to u prime v minus uv prime over v squared. Remember, in the quotient rule, u prime comes first, and there's a subtraction in the numerator. We're going to identify u is equal to the sine of t, and v is equal to t plus the tangent of t. Therefore, u prime is equal to the cosine of t, and v prime is equal to 1 plus the sine squared of t. That's because the derivative of t is equal to 1. You can use the power rule for that. And the derivative of the tangent function, I wrote sine, how silly, is the secant squared. So let me restate. The derivative of v, which is t plus the tangent of t, is v prime equals 1 plus secant squared of t. My bad. Y prime, according to the quotient rule, is going to be u prime v minus uv prime over v squared. And so y prime is equal to the cosine of t times t plus the tangent of t minus the sine of t times the quantity of 1 plus the secant squared of t all over the quantity of t plus the tangent of t squared. Now, as you know, when you start multiplying trigonometric functions together, they can start to take on different forms. So we're going to distribute in the numerator and see if anything simplifies. We start with t times the cosine of t plus, and I'm of course distributing the cosine of t into t plus the tangent of t. The tangent of t is the sine of t over the cosine of t. The cosines divide out, and I'm left with the sine of t. Then I have negative sine of t times 1, so minus the sine of t, and I can see that this simplifying is going to pay off because those are going to subtract out. Now when we consider the sine of t times the secant squared of t, that secant squared, it's 1 over the cosine squared, right? So what I'm going to do is I'm going to take one of those and put it as a denominator for the sine of t, and then I'm going to keep the other one as the secant of t. I'm also distributing the negative, right? So what I end up with is negative sine of t over cosine of t is going to give me the tangent of t, and that's times the secant of t. All divided by, there's nothing to be gained by foiling out the denominator. So t plus the tangent of t quantity squared. The sine of t is subtract out. Y prime is equal to t times the cosine of t minus the tangent of t times the secant of t divided by t plus the tangent of t quantity squared.